Hi, this is Jason Baker, and welcome back to our lecture on serverless and Lambda functions. So, we've talked about some of the use cases for Lambda functions and how you go about writing the Lambda function, creating the Lambda function resource, invoking the Lambda function, monitoring it. We've talked about how AWS creates this Lambda execution environment, which is really nothing more than a container. Each Lambda function invocation is executed within a separate container, and there are some performance considerations you have to think about. You have to think about cold starts versus warm starts, and the fact that there are different types of Lambda functions and different programming languages might have different bootstrapping constraints. The focus of this part of the lecture is on actually writing the Lambda function and the Lambda programming model that you follow. You can't just sit down and write any code that you want. You have to design your code in such a way that it will actually work properly within the Lambda execution environment. And in order to understand how to do that, you have to be familiar with some of the common components that you'll find and discover when working with Lambda functions. And these components apply to every single programming language that you would use when creating a Lambda function. The first component is the handler. The handler is nothing more than the function that Lambda will call when it begins to execute your Lambda function. So you can think of this as being sort of like the main function in the Lambda function code. The event is an object which is being passed into the handler function, and that event contains some event source information and parameter values. Remember, a Lambda function has to be triggered by some sort of event. And whatever is triggering that Lambda function is going to pass an object into the Lambda function, which contains some information about that event. Also, when you're invoking a Lambda function, a context object is created. And a context object contains some runtime information about the Lambda execution environment. A Lambda function can use the context object to basically get some information about the environment in which the Lambda function is running in. If you're using a platform like Node.js to write your Lambda function, you can optionally include a callback object. And it's commonly used in asynchronous platforms like Node to return values back to the caller of the function. And then finally, a Lambda function, a handler, can optionally return some sort of value. For example, if the Lambda function is being triggered by a web request that's coming through something like an API gateway, the Lambda function can handle the request and then respond to the request with some information. So it can send maybe an HTTP web response uh, back to the API gateway, which then passes it back to a customer's web browser. So the Lambda function takes in an event object, and then it can return something back to whatever called and invoked the Lambda function. Let's look at some of these components in more detail. Probably the most important component is the handler function. Again, this is the function which is invoked by the Lambda service when it runs your Lambda function. This is like the main, think of this as like the main function. And you specify this function when you create the Lambda resource configuration. You have to define specifically what the name of the handler function is going to be. And it uses this two-part notation, which is separated by a dot, where it's the function file name dot the function method, which is going to be the handler. So for example, you might have, here's an example where you're defining a function name. It takes in an event object and a context object, and then it returns some sort of value. A very simple Python example would be to define a handler function. In this case, the handler function is called my underscore handler, and it takes in two objects, an event object and a context object. And these objects are always going to be there. So by default, so your handler, uh, it should be designed to pass in these two objects. And then in my actual function, I'm creating a message, and that message is a string hello, followed by a parameter value that's interpolated, and the value of that parameter is going to be formatted with an attribute within that event object that's being passed in to the handler function. So in this case, we're assuming that there's an attribute called first underscore name that's being passed in as part of this event object, and we're going to create a string which precedes that value by the word hello. And then we're going to return that message. We're going to return a JSON object here with an attribute called message, and the value of that is the message string that we created. Very, very simple function that takes in an event, does something with the information from that event, and then returns another object. Again, the key to the handler component is that this is the function that is going to be the first function that's called by the Lambda service when that function's invoked. The event object is going to be passed to the handler function by whatever event source is triggering the Lambda function. And the format of this event object can vary greatly depending upon what type of event source is triggering the Lambda. For example, you could trigger a Lambda function using a CloudFormation template or API gateway or S3 bucket or Kinesis stream. I mean, there's dozens of different ways to trigger a Lambda function, and each source that's triggering that Lambda function is going to create an event object and pass that object into the handler function in the Lambda function. Here's an example, and I provided a link here showing you a list of event sources, and that's what's really handy about this list is it shows you an example of what that event object looks like. Remember, this event object is really just a JSON object, and here's an example from a CloudFormation. So if we're creating what's called a custom resource in CloudFormation, that can be used to trigger a Lambda function, and CloudFormation will actually pass in an event object into that Lambda function. And that event object is this JSON object that includes all of these different attributes. Your Lambda function then can access these different attributes as part of its execution and as part of the business logic. The context object is also passed into the Lambda handler function, and the context object allows you to interact with the Lambda service and execution environment in order to get some additional runtime information. So for example, your Lambda function can only run for a certain amount of time before it will be automatically terminated. And at the time that this video was recorded, that maximum amount of time the Lambda function could run is 5 minutes. After 5 minutes, the AWS is going to terminate the execution of that container environment. So there are cases where your Lambda function wants to know how much time is remaining before the Lambda service terminates the running function. It can get that information uh, by accessing the context object. The Lambda function might want to know where the function is logging to, which CloudWatch log group is associated with that running function. That's also present in the context object. And there are different methods and attribute names that you can invoke to access this information. I have an example here in Python where this is a method that we've created. We're passing in the context object, and we are returning a method that's made available to us. The method is get remaining time in milliseconds, and that's going to tell us how many milliseconds are remaining in the execution time of the Lambda function in this particular invocation. The I mentioned earlier that when we're monitoring Lambda functions, we're doing troubleshooting work, that we can log information out to CloudWatch logs. And the way that works in terms of programming and designing a Lambda function is that if, anything that is written to standard out or standard error by the Lambda function is going to be written automatically into the CloudWatch logs. And so every time the Lambda function is invoked, anything that's written to standard out or standard error is written to a CloudWatch log group. And it's fairly common to implement some sort of platform dependent log library so that you can get more detailed logging information, such as the log error level or the timestamps that are associated with logs. For example, if you were using Python, you could import the logging module and then use the logging module to output more detailed logging information. And all of that will be written into the CloudWatch log group. Sometimes the people who are new to Lambda functions, they have trouble finding the logs for their Lambda function. You can find those in two different ways. You can either go to the Lambda function web console in AWS and select your Lambda function. And you'll see that there's a log tab that you can click on to view the logs associated with that particular Lambda function. You can also go to the CloudWatch logs console, and then in that console you can search for the specific log group name and then log stream for your Lambda function and find it that way. Sometimes I find that it's easier if you're just troubleshooting and you're sort of building your Lambda function from scratch. It's easier while you're designing the function just to go into the Lambda console. Otherwise, in practice, if you have a Lambda function in production and it's getting millions of requests, then it's easier to go to CloudWatch logs or even potentially take those logs and push them into some sort of log aggregation and analysis solution. When you're testing Lambda functions, there's and you're writing your Lambda function code, there's a couple of different ways you can go about trying to troubleshoot your functions. So you've written your function, you've deployed it, and now you're invoking it. You can use the AWS Lambda Web Console to create test events and to sort of simulate the invocation of your Lambda function. And when you simulate the invocation, you can actually pass in an event object that you are creating for testing purposes. And so that can be an easy way to test the invocation of your Lambda function and to verify that it does what you expect it to do. You can also deploy the function into Lambda And if it's connected to something like an API gateway, then you can trigger that API gateway using a development tool like Postman to simulate API requests and generate different sorts of events. And that can also help you exercise these Lambda functions and troubleshoot and validate their functionality. And then finally, there is unit testing available. So you can develop your Lambda function locally and then uh, unit test the Lambda function using various fixtures or mocking frameworks. And I included links to two different frameworks that are available. One is called the SAM CLI, and another is called Placebo. And there are other various mocking frameworks that are available. I've worked with teams, for example, that are developing .NET Core uh, based functions, and on their local laptop and in Visual Studio, they can write unit tests and troubleshoot and mock their their Lambda function just like any other .NET Core application. And so they can use that sort of testing process, and they actually can build it into our software build pipelines as well, so we can effectively unit test our Lambda functions and test them before deployment.